Man, I'm like the smartest idiot that I know. I can't believe. Just can't believe. You know, I'm not even gonna edit that out because like I said the other day, this is real life, and sometimes in real life we do really stupid stuff. Ladies and gentlemen, boys and girls, viewers of all ages, welcome back to the channel. I'm glad you guys are here. I know, I am super glad to be here as always. In this video, we're going to return to the ongoing Ls4 V8 engine build that started from a camshaft swap. There's been a few other videos on this particular engine project, which had come out of a 2006 Chevrolet Monte Carlo. It's the SS front-wheel drive hot rod car. See, it's got the transverse transmission right here. All front-wheel drive. The customer had brought it to us to have some cylinder head work done, and we were going to do the DOD/AFM delete utilizing a camshaft swap. Now, what we had found out when I tore this engine down is, well, basically, let me back up. I made the critical error of looking at the cam bearings when I pulled the cam out. And that's kind of the joke amongst the LS enthusiasts, is the cam bearings are fine until you look at them. And I looked at them. We had found a little bit of copper that was showing on the bearing surface, indicating some wear. So we decided it was going to be better off while we're in there to just go ahead and knock the cam bearings out and pretty much do a full-on refresh. So what we've done is I've ordered cam bearings. We have piston rings, which were installed in a previous video. So we've got rings, bearings, crankshaft bearings, and connecting rod bearings. So we're refreshing all of the friction material areas on this particular engine. So what we need to do now at this point is get all 5 of these cam bearings knocked into place. And once those guys are pressed in with the appropriate tool, right here, once those are pressed in, we can go ahead and start cleaning up the bearing surfaces for the crankshaft. We'll get the crankshaft set back in. Once that guy's in, we can start getting pistons installed one at a time. So stay tuned, because this is going to be a very good part 4 engine build continued video. Okay, so in each individualized box here, we have the GM updated camshaft bearings. So we've got 2 running the part number 875, 1 876, and then 2 874s. And those are location specific to the engine. There are some slight differences. We're talking a couple thousandths of an inch with regards to the inside diameter of these things. So we need to make sure that the correct cam bearing goes in the correct location. Now you can get these as a whole set, not from GM, but again, the GM ones have a slightly updated design, and that's the one we wanted to go with. I believe the update is actually a larger oiling hole right here. That way, if you don't clock these bearings exactly true, you don't end up blocking off the oil passages that are machined into the blocks. So let's go ahead, and I need to figure out which part numbers go into which locations. We're going to grab the camshaft bearing install/removal tool, and we're going to drive these new units into place. And once that is done, we can move on with a couple other items on this particular engine. Okay, so we've got our bearings here. We have the part numbers, and I'm going to paraphrase them now. We got the 7.4s, the 7.5s, and the 7.6s. So pardon my chicken scratch, but I have transcribed the specifications for these bearings based off part number. So the 7.4 part number, internal diameter 2.353 to 2.354 inches, okay? 353 to 354. Part number 7.6, which is position 3, that's the center of the engine block, that one has a slightly smaller internal diameter at 2.314 to 2.315 inches. And then positions number 2 and 4, which are the next one in from the back and the next one in from the front, those came out at 2.334 inches. So we're only dealing with like 1 to 2 thousandths of an inch difference, but in this application, that is significant. And I believe this is the updated specifications along with those oil holes for the next generation of these bearings. It's a problem-solving solution, so to speak. So what we need to do is we're going to start on position 5. That's the furthest one from the front of the engine because we have to install these from the front side using that extra long tool. So let us get position number 5. We're looking at part number 874. So that's this set right here, the 874s. Ooh, that one's wrapped up, unlike the others. And there is a part number engraved on this. Hope you can see it, but it is ending in the 875. So this is our position 5 bearing, as well as our position 1 bearing for later. This one will go in last. So this one's first, this one's last, these two go in the middle. Let's get it installed. Okay, so now we know what we're doing, why we're doing it. I'm gonna show you guys how we're gonna do it. And it's gonna be achieved with the use of this install tool. So for starters, you'll notice it's got this sliding cone on it. This cone is supposed to fit in the first cam bearing journal. That way it helps to line this assembly up so when we drive it in, we don't drive those bearings in sideways and then ruin them. So what I shall do here is we take our bearing, and that's going to slide over that machined away section of this driver tool. So the tools drive against the bearing in this location here, and then it will be pressed into the appropriate race within the block. So I will insert the tool, bottoming it out all the way near that number 5 position. We'll take the, you guys see? Nope. The cam, or the first cam journal, is going to house this little cone just to center up this driving shaft slash tool shaft, whatever you want to call it. Now over here, what we've got to do is we take our bearing, and once all that is in its appropriate position, we can slide that bearing onto the tool. But we're not out of the woods yet because the holes need to be clocked properly at the 12 o'clock position, which is actually straight down in this configuration. We've got to line the hole in the bearing up with the hole drilled in the block. Now, to make sure we get this oriented properly, I'm actually going to mark the bottom of this bearing with a Sharpie. Now the bottom of the bearing, I'm sorry, the top from our orientation, which is going to be the bottom because the engine is upside down. So I'm going to take this thing and we're going to eyeball the correct alignment. So bear with me here. Oh, you know what? You guys may have caught this when I said something, but looky here. See how that bearing's just sliding in and out? I didn't realize it. You guys may have, but this is part number 192600875, but that came out of the box for 874. You see that? So this is not boxed properly. That is wrong. It's the wrong box. We need part number for position 5. We need 874, which is not that. I wonder if one of these is also improperly boxed. Let's find out. Okay, this one is also listed as an 875, which came out of the 875 box, so that's correct. But we need an 874. So let's try this other 874 box and see if this bearing is correct. Okay, so this one that came out part number 874 does not have a part number etched in it. So let's just see if this one is going to fit in that hole. Let's see what it does here. Okay, that's tight fit right there. So now we're kind of back on schedule, except for I have one wrong bearing. And again, we have to line up that oil hole with that oil galley right there. See that? So what I'll do, back to where we started, with the Sharpie, I'm gonna mark the bottom of this bearing so we can reference it and line it up properly. Once that's marked, we'll drive it in with the tool. Okie doke, so I have kind of a reference mark here, so this is going to point upwards at us. So what I need to do, now that we know which bearing is the right one and one was not boxed wrong or not boxed correctly, that could have been disastrous. I'm sliding this bearing over the install tool. I'm going to get it roughly in its position. Now I'm using this hole right here as the reference for the bottom of this at the bottom of the crank journal to reference my mark right there. So we got the mark set up. The cone in the front is right. So this is now in a good position for us to drive it home, I think. So where mark is lined up with the dot. And if we take a look, which I can't see, there's our oil passage for the cam, but we can't see the hole in the cam or in the bearing because the tool is in the way. Our cone here is set up, so now I just need to drive this guy in until it reaches its center position here. So you guys keep an eye on the bearing. I'm gonna drive it in with the mallet and we'll get this first one done. Okay, so I'm holding the cone with my left hand. I've got my foot at the engine stand so it doesn't walk away from us, and we're gonna start driving this bearing into position here. Tappy tap. See it going in? Almost. There's gonna be a lot of checking on this because I don't want to drive it too far. We could potentially drive this thing past where it's supposed to go. We're not in deep enough yet. A little bit more, a little farther here, a couple more taps with the mallet. Nope, not yet. Going in a little farther. Let's see how that's looking there. Okay, the tool's starting to stick out. And not quite there yet. Okie dokes. Let's see where we're at. We're protruding a little bit here on the tool side. So let's back the tool out and we can eyeball that oiling hole in there. So let's see if we can see what we're trying to see. And the survey says, look at that. You see the oil passage behind that oiling hole? All right, so that bearing is in. That's the number 5 position. Let's back out our tool and we're gonna move on to the number 4 position. Now keep in mind, I've got to order another bearing because this one is boxed wrong, but at least we figured that out before the critical error was made. Going over here, back to our paperwork. The number 4 position requires part number 875. 875, and this one is also an 875. Let's pull that guy out and we're gonna check it. 875 according to the etching. So let's repeat procedure with bearing number 4. Okay, Sharpie reference mark again at the top side. There are the 2 oiling holes here and here. One's for the oil passage and the other is just to allow oil a relief on the other side so it doesn't build up pressure on one side. Let's see, so this guy, I'm gonna drop you down. If I can squeeze it on in there, it's I have a tight squeeze. How'd I get this out? What is this? There we go. Reach around to hold it straight, get it lined up. See that? Install tool coming in, just like so. The cone sliding into bearing race number 1. Okay, we're lined up. Time to tap it on in and send this one home, and then we can make sure it is oriented properly. We'll do that visually. Beginning tapping procedure now. This one feels a little tighter than that first one. Okay, how's it hanging here? We're not sticking out of the back just yet. Let me pull the tool out and need to go in there with a mirror and check the alignment. Okay, mirror, mirror on a stick. Show me the hole. All right, we're not in enough yet. You guys see the hole right there? See how that passage is blocked? Let's give this a couple more love taps here with the tool, and maybe about 1/8 of an inch or so, and we'll look again. Let's see, put the tool back in the bearing, center it with the cone, tap it on in. Felt motion. Let's pull the driver out, and I'm going to go back in one more time. We need a little bit more. Not quite yet. The oil hole is exposed. However, it's not fully exposed. Going in again. And we're right on the money. I'm about a 32nd of an inch short. Let me give it just one more love tap in. We should be good here. That was actually like 4 taps, but you know, you got to get into the swing of things, so to speak. Back in with the mirror one last time, checking. And that is right as rain. Let me see if I can get you guys to see what I'm seeing here. Get you in a little closer down there. See how the hole's lining up with the passage? This one's good to go. That bearing will be oiled correctly. Beautiful. Okay, so what I want to do now before we continue with the additional bearings is I'm going to pull the tool out and get my hammer out of the way. I'm going to take the old cam and slide it in just so we can make sure that it's fitting so far and that all the bearings feel good and the alignment is correct and proper. Okie dokes, old camshaft coming in. I'm just going to slide her on in position in there. That feels really good, looks good. I'd say that'll do it. Let's go ahead and pull this cam back out, and we will get the rest of the bearings pressed in. This is the fun part. I like putting them together. It's more fulfilling than it is to take them apart. Okay, cam bearing part number ending in 876. Let's put our reference mark on it. So we've got there's the hole, there's the other hole, and right here, that's the top of our bearing. We'll visually confirm that. We're gonna eyeball it. Looks good. Let's get this next bearing driven into position. So, bring it in, twist it, drop it down, line it up. Looking good. I like it. Okay, the driver's coming back in. Let me get that lined up in the bearing, centering the cone. Hammer time. Send it. Halfway. Halfway there. A little more. Okay. Pulling the tool out. Let's go in for our visual inspection. We got to go about another 1/4 inch, I think. Mirror, mirror on a stick, tell me where my oiling holes are lined up. Yep, 1/4 inch is what we're looking at. You guys see the hole down there? A little bit more. Wee little bit. Lined up, cones in position, 1/4 inch. Now, if I go too far, it's not the end of the world because we can just drive the bearing out and reset and do it again. It's not preferable. I need, looking for about 1/8 inch, little bit more. Yeah, I think it's better to be a little conservative with how we drive this. It's kind of like cutting hair. You can always take more off. It's harder to put some back on. I filter move. Where's that hole at? I can't find my hole. That's it, right on the money. That's lined up perfect. Position number 2 is up next. Okay, so position 2 requires part number 875. I've already made the centered reference mark to get this lined up right. So we'll slip her on in, turn it, get it on the tool. We are aligned visually. Get the cone in, and time to send it. More. The engine stand is starting to rotate. I think that's right on the money right there. Let's throw the mirror down there and find out. Let's see. I can go for, you guys see the hole? I think I can go for another 1/8 inch, little bit more. Couple more tappy taps. All right, here we go. Right as rain, that one's good to go. Golden. Okay, so we have one bearing left. That's in the number 1 position right out front. Now we had that box mismatch. So the other one's on order again. As soon as that shows up, we'll get started on the next unit. Alrighty guys, it's actually the next day. I am still waiting on our number 1 camshaft bearing, and I'm sort of at a standstill on the block. I just took some pressurized air, blew everything out, tried to get it cleaned up a little bit, got rid of all the residual oil and little fibrous businesses that were left behind by the engine cover, just because I saw some of it. So it's been de-dusted. Again, I'm at a standstill right now, except for maybe I can do some work on the cylinder heads here. They've been to the machine shop already, and they didn't do a valve job, but they decked the head a little bit just to make it nice and flat-like. They put it in their chemical bath to clean it, pulled the valves out, changed out the springs, and they put in new valve stem seals. But it's not really as clean as I would have expected it to be, considering that I paid money to clean this, and it's not clean. Like some areas are clean, but some areas are not clean. So that one's okay, that head's decent. The other head had a broken exhaust manifold bolt in it. It shouldn't be too much agony to remove, We're just gonna weld a nut to it and just back the bolt out. I think it's this one down here. Yeah, see that? But again, I also want to get this clean because it's not, and we paid for it, and my customer paid for it. So I think what I'll do, I'm gonna bring this over here onto the toolbox, and I'm gonna bust out the welder, fire that thing up. I'm gonna weld a nut on that broken stud. I tried to dig it out with like a little pocket screwdriver thinking it might turn, but it will not. So we're gonna weld a nut onto that unit and get that stud extracted. Then I'm gonna bust out the walnut blaster, and we're actually going to decarbonize the bottoms of these combustion chambers, or the tops of the combustion chambers rather. We're gonna decarbonize it. We're gonna bead blast it and get rid of all the rest of the dirt. There we go. Words. We're getting there. I mean, you know, looking inside of these intakes, yeah, there's a bunch of carbon on that too. These things are filthy, man. These are, I don't even think they took the valves out of it to change the stems. Like, look at that. That's not okay. There's carbon everywhere inside of these heads. Yeah, I gotta finish what the machine shop started, and they were the most reputable machine shop in town too. Man, I gotta tell you guys what, I'm getting real tired of twice the cost and half the product. Like, I'm getting really sick of that. It's everywhere we turn, all of a sudden, it's twice the cost, half as much, and a third of the quality. It's getting ridiculous. I'm just gonna stop buying stuff. It's like, hey, inflate the economy till it crashes, because at some point people are gonna stop purchasing things and we're gonna enter a hyper deflationary period. Okay, so here's the plan. Gonna get that thing extracted so I can put the exhaust back together. Then we're gonna flip this thing over. I'm gonna bust out the walnut blaster. We're going to finish the machine shop's job of hitting these combustion chambers, and I'm gonna blast out the intake runners, make sure this is nice and clean. We'll do the other side, and then I'm hoping by then that other bearing will be here and we can get that bearing installed. So let's just, we're playing this one by ear today, guys, playing it by ear. All right, boys, get your welding goggles on here. So I've got a nut here, and hang on to it with some needle noses, and I need to shorten this. There we go. One more time. You know, I'm wondering if maybe I should try to build this up a little bit before I try to weld this on. Nah, we're just gonna wing it, see what happens. Okay, it's on. Stinky. I wonder if this nut is galvanized. It smells. Good. So, grab a wrench. I could probably wait for this to cool off, but you know, I'm impatient, so we'll just break it off a bunch of times instead. So it's either turning or the weld is breaking. Not really certain which one it is yet. A little more, a little more, a little more, a little more. I believe it's coming out. Yeah, I think it's gonna come out. A little more. Ooh, this wrench is already getting hot. I can feel the heat from all the way up to here so far. That's wild. Yeah, you guys, check this out. Watch this. There's the wrench. Got a thermal imager right here. Check this out. Look at how much heat is traveling up the wrench. Yeah, it's getting a little warm in there. I know, little fancy snap-on tools. That thing's actually more of a novelty, really. I used it, like I think one time to find an electrical short in a module in a Mercedes. It was a parasitic draw, and it was bringing down the guy's battery overnight. And he dealt with it for years. Like, he had a jumper box and a battery charger in the trunk of the car at all times. Yeah, that's definitely coming out. Now what I can't do is touch the other end of the wrench, so we're converting this to a stubby. Yeah, this is a lot easier to do out of the vehicle. There we go. So now, I'm gonna go out and get the walnut blaster, the affectionately named R2D2 machine, and we're gonna blast these holes out, get rid of the carbon, flip it over, do the combustion chambers, and then we'll hit the other head as well. So this is the walnut media blasting device. It's very similar to a shop vac with a few subtle differences. So we've got a vacuum pump in here with a filter. We've got the vacuum hose that recirculates everything that we blast out of the business end back into the hopper inside of the machine. So forgive me if you guys already know how this works, but there are new people here that do not. So we've got a filter, we've got our vacuum motor right here, and the filter is there to prevent the blasting media from just being sucked up into the motor and blown out of the exhaust, okay? Below that, we've got the dirty side of the filter, and we have a whole bunch of carbon chunks, a paper towel, and a lot of walnut shell, ground up walnut shell. And that's the abrasive blast media that we're going to use to remove the carbon deposits from these cylinder heads. So what we've got to do is connect the shop air to it, because we have to get the energy for the blasting somehow. And that's where the second wand comes into place. Like that. So watch this. Let me turn it off real quick. This is, oh no, here's our feed line. That's our feed line from the bottom of the hopper. Shop air comes in through this valve, and when you squeeze the trigger, it's going to create a Venturi effect, because it's blowing air over the opening for this hose and creating a negative pressure or a lower pressure inside of this hose. That's going to draw in the blasting media, and as it comes up and through, it's going to meet the high pressure, high velocity air, which is going to send that walnut media into our carbonated area. And I realize it's not a soda, but it'll send it into the cylinder head, blast away all the buildup, and then utilizing the vacuum side of it in conjunction with the pressure side, we can recycle the media and continue blasting and blasting and blasting until the thing is entirely clean. So now that we know what we're doing and why we're doing it, let's start doing it. Powering on, like so. Semi-loud noises, bear with me here. I hope the noise canceling works. Actually, real quick audio check, you guys, since I'm working out this new mic. Right now we have noise canceling turned on, and this is noise canceling turned off. Can you guys tell the difference? Let me know which version of this you would like to hear for future videos. Noise canceling off or noise canceling on. Please register your opinion in the comment section down below. Okay, so in order to not blast nuts all over my box, we take the business end where the walnut is expelled from. We're gonna shove it in this little hole right here in the front. We're gonna push it down all the way till it sticks past the rim, okay? So now we can hold this against the head, and utilizing the trigger over here, we can blast those walnuts all over the top of these valves. Yep, see the walnut running through the hose right here? So we are blasting currently. Let's see what we get out of this unit. Now, I realize that this is not the most visually appealing because we can't see the process as it's taking place, but take a look at that top of that intake valve right there, and then take a look at the top of that one right there. That one's nasty. So let's fire the machine back up. We'll hit this one and see how well this one cleans up. I love this machine. It's like the best 300 bucks I ever spent on Amazon. Okay, next hole. Blaster going in, sticking out past the rim. Send it. A little more. That's the grody one in there. That's beautiful. Take a look here. Yeah, there's still some really hardened carbon built up on that valve stem, but for the most part, this thing's pretty squeaky clean. Let me knock the other two out, and then we're gonna flip this over and we'll do the combustion chambers as well. I got walnut in my mouth. It's hot in there. It's really, really hot in there. Okay, so let's power down the R2D2 blaster over here because it's loud and noisy. Let's do another finalized inspection here. So you see there's still a bunch of walnut in there. We've got to blast all that out with some just some pressurized air. But it looks like these intake runners are super duper clean. So let's give this guy a flip, roll it over, and we'll go after these combustion chambers next because those are that's just not okay. I'm not putting that on like that. It's gross. It's ugly. No. Blaster powering back on. I have the noise canceling off, by the way, so I hope the audio did not get horrendously terrible. I didn't want it to go silent. Now this is a little bit harder to do, I think, because this little system's not engineered to operate the way that I'm operating it. Go figure. But, I mean, I don't follow directions. We'll see how this works out. Yeah, that's nice. Yeah, this is gonna work. We'll get it clean. We'll get it. I'm losing my nuts. I'm eating nuts. Yeah, that's a lot better. Much better. Next. Ah, my hose fell off. Fixed it. That's baked on there pretty good. That's not coming off. Anyway, one more to go. Last one. Hey, you guys wanted an update on that Chrysler van with the blowed up engine, right? Here it is. Yeah! There's the update. Here it is. Yeah, the Eric from I Do Cars still has the engine. It's in progress. They just got slammed and wrecked with like a nasty hailstorm, so he's delayed a couple days because he's got to do storm mitigation or whatever. But regardless, it is in progress. We're going to start pulling that thing apart pretty soon to get the old unit out of it so we can get the newly constructed engine placed back into it. And right now, this Chrysler, the one that we did the cams and lifters, or we did lifters in it, lifters and rockers, this one set those two DTCs. I made a video asking the audience, you know, hey, what happened here? I thought we had the thing out of time. It turns out that somehow, some way, a piece of metal must have touched these camshafts, and that took out the pickup wheel for the camshaft position sensors. So, we had to put an exhaust cam in it, not that one. And having pulled that, or after we put that exhaust cam in, one of the codes went away, but we still had another code. So we're stealing an intake cam out of that dead engine, and we're gonna put it in this not dead engine so we can get this thing fixed again. Okay, loud noises. I found my blowgun. shiny-ish. But what really matters is going to be all the walnut pieces down inside these intake runners. And let's blow the exhaust side, intake side. What am, oh wow. I just had the worst absolute brain fart of my life. I cannot believe I'm over here blasting the exhaust valves thinking they're the intake valves. I did not just do that. Idiot move, oh my God. Okay, well this side's clean, so I take back everything I just said. I guess we cleaned out the exhaust side. Anyway, the valve faces look better and the combustion chambers are clean, and that was kind of the goal. I really can't believe, how many of you guys caught that before I did? I can't believe I did not, it didn't occur to me. These are cathedral port cylinder heads. They're all this shape, not the other shape. Shapes and colors, Ray, come on, man. Well, regardless, we still had to clean the walnut out of it, so whatever. That just means now I have to walnut blast the exhaust valves on the other head just to make them match the valves on this head. Plus, it's more high performancer. There we go. Good to go. Man, I'm like the smartest idiot that I know. I can't believe. Just can't believe. You know, I'm not even going to edit that out because, like I said the other day, this is real life, and sometimes in real life we do really stupid stuff. That was definitely one of them. I wish I had a better excuse, but I don't. It is what it is. So anyway, let's fire this machine back up. I'm going to hit these combustion chambers. We're going to blast out the exhaust valves as well. I don't know why, but I have that song Kung Fu Fighting stuck in my head. Dave, is that my bearing?
Yes, it is.
My man. Thank you, sir. Good timing.
Came early.
Yeah, I know, right? They said 3 o'clock and I was upset, and now it's not 3 o'clock, which is good. That means somebody lied to me and I'm upset about that too. Hey, I just want to be moody. Everybody was Kung Fu fighting. Those cats were fast as lightning. They're just like, what is wrong with this guy? What is wrong with you?
It was so funny to watch.
Because I was Kung Fu fighting.
It's never boring here.
Yeah, sometimes. It can be boring sometimes, but it is what it is, yeah. Alrighty guys, I've got the cylinder heads back over here in the work area, and we have our correct part numbered camshaft bearing for the #1 position on the front of this block. So let's go ahead and finish off the cam bearing install. I've just gone through and blown this thing off with a bunch of air, get rid of some of the dirt and whatnot. So we're ready to get this next bearing kind of pressed into position here. So let's get it kind of lined up, and I'm gonna grab the tool and we'll send it in. So here, let's get this thing set up in here. Right in the hole she goes. And my mark between the the oil holes there is centered and facing straight down on the engine block. So I'm gonna go ahead and start tapping this unit in. Begin install now. See how far we got. I'm thinking I'm off center. Uh-oh. Oh, hang on. No, I'm not. I'm right on the money. Check it out. Let me get a light on the subject here. Yeah, see the oil hole right there? You can see the passage right behind it. This thing is right on the money. That was dang near perfect. Okay, I think we're ready to rock and roll. Let me grab some assembly lube. We're gonna crack open that camshaft in the box over there, and we're gonna get that thing slid into position. It's time to build an engine now. Here, let's do this. Let me swap out the box for some fresh, clean towel. Stay. Just gonna go over this and give it a wipe. It's got some oil on it, but the instructions on the back said to please wipe it off and make sure it's clean, so I will do such things before we apply assembly lubricant. A little bit of something on there. I don't like that. See that speck? A little speck of some kind of contaminant. Hope it's not rust. What is that? Looks like a job for a brake clean or a Ziz wheel. I'll hit it with a sander. There we go. Here, we'll throw some brake clean in it, or on it, add it, around it. One of those adjectives. Okay, it's coming off, whatever it is, but it's on there good. Okay, so now let's start getting some lubrication on this thing. So here, and here, these are the areas of the cam that ride on the bearings that we just installed. The lobes, these are where the lifters ride, which sit down in the block under the cylinder heads to actuate onto the push rods, and then those actuate the rocker arms. So we need to add lube. Well, the whole thing needs to be lubed, but especially on all the bearing surfaces, because on first startup, that's going to be the spot that is going to be experiencing some engine wear. So what I'm thinking is we'll go ahead and apply assembly lube. What I have here is Permatex Ultra Slick Engine Assembly Lube. This is stuff I've been using for years, and I'm a creature of habit, so I'll just continue to use what I know is good. We'll start, and I'm going to bring the lube over to the engine. We can start here with do the first couple lobes. We'll insert this unit, then get the next couple of lobes, and I'm also going to squirt some assembly lube onto the bearing surfaces in the block. That way we're lubed everywhere. So let's head over to the engine and start sticking our shaft in our lubricated holes there. I made a mess. Get some on the cam lobes too. It's all got to be soaked with lubricant. It's red, so you know it's good. So, like I said, I want to put some lube on the inside of the bearings here. That way both surfaces are lubricated. We'll get all 5 of them. Next little dab. A little bit more. Okay, that's good. Put that down for in a minute. Let's go ahead and start inserting the cam shaft. Now we've got to make super extra careful sure that we don't ding or nick these bearings, because these tolerances are gonna end up being pretty tight. Let's drop some lube on the lobes here. I'll have to re-lube these again later, but just to get a good coating on it at first couldn't hurt. There we go. So it's not the bearing section that's of the major concern going through these bearings, it's the lobes hitting the bearing you got to worry about. We don't want the lobes to nick the cam bearings here. Going in. Let's stop right here. And if I'm doing it wrong, you just guys, you feel free to let me know in the comment section down below. I don't think I'm doing it wrong, but there are some that know more than I, and I listen to them. Usually. Okay, continuing the insertion procedure. I'm reaching around with my left hand, going through each cam bearing, and I'm guiding it in on the backside, so it's not just in there flopping around all willy-nilly like. Yeah, I think the whoa, gravity. You guys are dead. Take two, trying again. So I think the update with this melling cam plate here is the way clamping force is applied. You see the tapered screws in it? Little hex or what are those, Torxes? Those are Torx screws. There was some type of an update with how they beveled these screws or how they made them fit against the plate, and that provides better clamping for us. I guess these things used to leak. Anyway, let's get this thing bolted on real quick. That way when we put the cam in, it can't slide out through the back side of the block. We need this. Okay, so up top, before we finally send this thing home, we put a couple more drops of lube on the bearing surfaces, because the rear ones, the lube was scraped off by said bearings as the cam passed through. So adding a little bit of extra lube on there. Now we can finish getting this thing in position here. Then we'll throw the front cam plate on it and get that torqued down. And then I think we can probably set the crankshaft down in there after that. Cool. So I was faced with two choices, because during editing I realized that this particular scene did not have any audio, and I do not know why. However, I wanted to include it to illustrate that this is a melling updated cam retainer plate. And I came to find out that the factory style plates had just a regular bolt securing the plate to the block, and if they were ever over torqued, or if they were worn from the bolts being torqued, they could crack and then cause a lack of clamping force, which would then cause this plate to leak. So it appears that the update is to, again, use these tapered screws in order to achieve more surface area to apply the clamp force to the said plate. So let's see what we get here. That's 11 pounds. Torqued. Torqued. Torqued a little more. Recheck. Good, good, good. And this one also good. Now, since we are building an engine, we want to do this the right way. I'm going to paint mark everything that I torqued so we know that it's been torqued. Like so, like so, like so. Yoda fall, look at that. I like it. So while we're here, let's go ahead and get the gear installed on this unit. I have it backwards. Silly rabbit. Was it backwards? No. No, it was not backwards. Okay. I had to push the cam a little farther forward. Clearances in here are very, very, very tight. So I've got new fasteners to go with this. I think you can reuse the old ones, but I got a set of ARP, that's automotive racing products. I put ARP bolts in for the cam, because it is a hot cam and it couldn't hurt to put new bolts in it. There we go. Alright guys, now we're getting to the good stuff. It's time to get the crankshaft dropped down into position. So let's bust out the crankshaft bearings and get them placed in their respective homes. Now, I'm not going to plasti dip these. We're not gonna go through them with a micrometer because there's no need to. Reason being, there has been zero machine work done to this engine block, and these are factory spec'd bearings, so we do not need, for any reason, to go through the arduous task of plasti dipping these units,
Plasti gauge,
and measuring them with a micrometer and all that good stuff. So we're dropping them in, wiping it down, not in that order, and then we're setting the crank in. It's going to be fine, don't worry. And like I said, we're not building a NASCAR engine here. It's a Monte Carlo. You know, I've actually got to rephrase that. It's a front wheel drive Monte Carlo, because I am aware that NASCAR ran Monte Carlos. Make sure this is all clean and dust free, and again, I'm going to blow it all out just to make sure, but I got to wipe off whatever I can see, and I did see some cardboard box debris on there. So our center bearing here, this one also contains a component called the thrust bearing, and this is the unit right here that keeps the crankshaft in line forward and backwards. So there's a bearing surface here, another one here, and then the other half also has bearing surface on it. So if the crankshaft wants to go that way, it'll ride against this surface and prevent it from digging into the block, and if it wants to go that way, it'll ride against that back surface and do the same thing. Shoo, let's get the 1, 2, 4, and 5 bearings dropped in, and then we'll lube these up and then set the crank down into its position. Gravity. That was microphone gravity, guys. Okay, next bearing coming in. You can't get these in the wrong spot because they've got these little tangs on them. See that tang right there sticking out? That fits into a notch right here, cast into the block. So we just kind of line those guys up and then press them down. Okay, next one. Keeping an eyeball on that tang. Just kind of drop that in and give it a push. And the bearing should words sit flush against the top of these the mains right here. Push that next one in. Push it flush. There we go. That's 2. Let's get the 2 out back. And all of these bearings are the same. They're not the same as the camshaft bearings where they have 1 1,000th to 2 1,000ths difference in diameter. Those are all exactly the same. All right, loud noises. Time for a little bit of air just in case there's any little fibers in there. Little cardboard specks or whatever, get rid of it. There we go. All right. Loud. Don't need that. So now, let's go ahead. I'm going to drop some assembly lube onto these bearings. We'll smear it around some. And then drop that crankshaft into its home position. Checking the glove, looking clean, no debris. Be quite generous with our lubrication. Going to coat that whole surface. Some on the sides here. Speaking of lubrication, I have selected Amsoil break-in oil for the cam and ring break-in on this. It's a high ZDDP and low detergent oil, only for break-in, so we're not going to run it very long. There we go. Okay, those guys are in good shape, looking good. Words. Let me go blow the crankshaft off, and then we'll drop that down into position. That did not sound right at all. Oh my God. Cut. Okay, now that my shaft of cranking has been taken care of, I'm going to go ahead and set her down into its home. making sure we don't bang anything and cause damage to this unit. Line it up, drop it in. There she goes. That's in position. Okay, so now I'm gonna throw some more assembly lube on this. I've gone through and you'll see all these oiling holes. See these guys right here, all those oil holes? They've been blown out extensively with shop air. I'm just gonna go ahead and throw in some lube inside. That's gonna do a couple things for us. It's gonna give us a little bit of reserve capacity on startup because there's already oil in the journals, and it'll keep some rust from forming inside of there should the conditions be present to allow for rust. There shouldn't be, but you never know. Throw some in there. Got that one, got that one. Let's get this one right here. And a little bit more right in there. There we go. Okay. We are now lubricated. Throw a little bit more on there. Looking good. I'll take that. I know it's probably a little excessive, and the old guard's gonna tell me, no, don't do it. But see, look, we have reserve oil right there. And I'm not feeling much for in-play either. Beautiful, look at that. That's nice and shiny. It's not really shiny, but it feels shiny. All right, time for the caps. The caps contain the matching counterpart for the bearings that we just put into the block. Those guys are in position. Now remember the tangs we talked about? Those go opposite of each other on either side. So the tang is on this side of the block, on the block side, and the tang will be on that side of the block on the other side. And what those tangs do is they prevent the bearings from having an opportunity to rotate and turn while inside of their race, hence the term spun bearing. They kind of lock those bearings in so that they can't move and they can't turn that way. So there's our center one, which contains the thrust bearing. Let's get the remaining units in position. And you see I've got some lube on them. Drop this guy down. Please go in your home. What are you doing there? Good. Silly rabbit. Put it on backwards. There we go. Good. Let's drop the rear unit in next. Drop you down in there. And remember earlier when we took those apart, the little pointers were opposite on this one in the back. And you can't get it backwards, so no worries. Well, shucks. Looks like I lost some more audio as we're putting the camshaft caps back in. We've moved on to the very front one. We set this guy down, and we're gonna go ahead and fetch the bolts next after I take a mallet and seat these caps flush against the block. They're very tight fitting due to the clearance at the skirt, so once everything's lined up, you just got to give it a couple love taps here just to seat everything. That way, in case there is a misalignment, it can be corrected before applying torque with the bolts. Because if you try to torque something that's misaligned, it may actually lock into that position and be incorrectly aligned. And we don't want to do that while building engines. So going through, all of these appear to be seating very nicely. Take note, do not hit that crankshaft position wheel at the back side of the camshaft with a hammer. If you damage that, the crank position sensor will not pick up the crankshaft's position, and it'll run very poorly and give error codes. End of disclaimer. So when it comes to the cap bolts, there are two different style bolts, and both of those are an unequal length. So the longer bolts, I believe, go towards the center of the cap, and then the shorter studs go on the outer side of the cap, and those are there with the studs in order to provide an attachment point for the windage tray, which is sitting over in the parts washer right now. So I'll go ahead and drop all these guys in. These are not torque to yield bolts, and they are reusable. And again, we're a little over budget here, so I'm trying to cut as many corners as possible when it comes to the cost. For example, a set of LS main bolts, I believe, are
like
let's see here.
$160.
Pulling up the
let me look
Google
that up real
machine.
quick.
Let's just check on ARPs, because if I'm gonna replace expensive bolts, I want to have the best bolts we can get. So it's probably going to take us to Summit. They've got a stud set for $230 something. Next one, those are cylinder head bolts right there. I do have a set of new cylinder head bolts because those are torque to yield. And it looks like the stock set, or maybe half the stock set, is $50. So yeah, so anywhere between $54.99 and $240 for a set of bolts. Either way, we can reuse these. Plus, we're not building a NASCAR engine, so it's fine. Anyway, let me run these down. Not applying any torque to them because we have to torque these in stages. So I'm just gonna run these down till they're bottomed out. I have already blown out and cleaned the thread holes in the block casting. If you attempt to put these types of bolts in and there's, like, let's say oil or some kind of fluid down in those holes, you will hydrolock that hole and crack the block when you go to torque the bolt down. Yeah, it's a fun fact. Don't do that. It'll ruin your day. So anyway, let me break out the torque wrench, and like I said, we've got to do this in a couple stages, and there is a sequence starting from the center, working our way out. And actually, at the moment of editing, I don't recall what the actual spec was. Let me see if it's here. We're looking, I can't barely see it from the phone view. 15 foot-pounds of torque for the first pass, and 80 degrees. That's going to be on the bolts, and the studs are also 15 foot-pounds on the first pass, and then we have to go in for, again, 80 degrees. So the 15 pounds is just to make sure that the caps are seated properly and evenly. We're going to go through and click all these guys. There we go. So we're on to the studs next. Oh, did you hear that? The audio tried to come back. That's that silly cable connection that I failed to properly establish on this microphone business. I really like this microphone, but I keep messing it up. It's like it doesn't fit into my style of existing. Anyway, I'm almost done with the sequence on the studs. We are all at 15 foot-pounds. We have to torque these ones all down first, and then we do the side bolts afterwards. So we're at 15 pounds. I need to set up the 3/8 torque wrench that will measure our degrees. We got to run these down to 80 degrees per bolt, and then these end caps will be torqued to specified specifications. Okay, I believe audio is back again. I made an operator error, and I had my plug plugged into the wrong thing. So we had about 4 minutes of footage with no sound or intermittent sound. Regardless, I've got the beeper wrench out, and it is set up for torque in degrees. So we're going to do this 80 degrees per bolt. So we should end up with the wrench facing right around this direction as we reach the 80 mark. So here we go. We're beginning our sequence: 30, 40, 50, 70, almost 70, 66, 78, 79, 80. That's 80 degrees on that one. and it relaxed at 71 according to the wrench here. So I'm wondering if I should run it a little bit harder and bring it up to the 80, or if we're good here, because that's 71 where we sit. We'll go a little farther, because it's the wrench that's flexing, not the... Yeah, that's it. We're going with that. I'm gonna go till it beeps. So need to reset. 80 again. We did this one. Let's do number 2. I'll keep the vocal commentary to a minimum just so I can concentrate on this and get through it the correct way. $80. Okay. Each of these bolts is going to get a paint mark on it. So final torque has been achieved. Let's pull up my dealio here. That's 1 and 2, 3 into the 4. Ha, there we go, look at that. Stick the paint marker right inside of here. That's brilliant. Now we're using our noodle, kinda. Okay, we ready? Let's back up some. $80. Reset. $80. Paint. Paint. Reset. Okay, 5. Doing 5 and 6 next. Let me brace everything so I don't twist it. $80. $81, but I'll live with it. Paint and paint. $80. $82, but I'll live with it. Paint, paint. And the next two are 9 and 10. Those are out back over yonder. $83. I went a little far on that one, but I'll live with it. Since that one's 83, I'll do this one at 82. There we go. Marked. Marked. So that is our bolts on the inboard side. Let's do the studs on the outboard side next. So that was position 10 we just finished up with. Moving to position 11. That's going to be this one right here. So I need to switch out to a 15, which might be in my pocket. Yeah, but it's quarter drive. Hang on, other 15. 3/8 drive 15. Okay, here we go. 80 degrees on the second pass. Ooh. I have to redo that one. I didn't have the thing set There. It did not start counting when I started rotating. Ah, I did it again. It still didn't set. Come on. Killing me, Smalls. So we'll back it off. Bring it up to 15 foot-pounds. There we go. $70, $80. $80. $80. $80 degrees. So that's 13 and 14, 15 and 16 are next on my list. $80. $81, I'll live with it. That was 16 and 15, so 17, 18 to our left. 17 is that one there. $80. There we go. Got it. And 19 and 20. Torquing is tiring. It'll get you. It will. Oh yeah, paint. Give me a minute. Paint here. Gotta get the paint. That one, I didn't have reset. Bear with me. Gotta do it the right way. 15 again. $80. Hot. Good thing I got that fan on me. It's 94 degrees today in the shop. $82. I'll live with that. Okay, all these units are torqued to the specified specifications. And the survey says that's golden. Beautiful. All right, guys, so I'm losing audio again. The thing shut off because it's hot or it's out of battery or both. But at this point, I have the crankshaft installed. We are all torqued to spec. The next thing on the list is going to be the side bolts and any other supporting hardware that bolts on the side of this engine. Crankshaft position sensor. Again, side bolts for the connecting or the camshaft, Crankshaft end caps. There we go. Words. Now, GM says that I can reuse the old ones if we were to clean the sealant off of them and then apply new sealant. Reason being is oil can make its way into and between these areas here, and then it can find its way out of the threads. So they want you to have a little bit of sealant on the threads and on the face of the bolt to prevent oil from coming out. That's the only reason that GM says that you cannot, or that's what they say that you have to do if you wish to reuse your bolts. If not, you got to buy new ones. I think I might have new bolts here, but I don't see them right now. They might be on ordered and they're just not here yet, so I have yet to determine that. Regardless, that's inconsequential, because the next phase of this engine is going to be getting the pistons installed and bolted to the crankshaft. The last episode, I think we got the connecting piston rings installed and clocked properly, so we just need to get each of these slugs into their respective homes over here. I've got a piston ring compressor over yonder, specifically sized for this exact application, so that should go fairly smoothly. However, I'm going to save that video or that operation for the next video. This one's reaching my normal time limit, so again, I'm going to go ahead and close this one out right now. I will do that as always by thanking each and every one of you guys for watching this video. Let me know what you think about this situation, this engine build, and this Monte Carlo in the comment section down below. Do not forget to engage that like and subscribe button while you're down there. And most importantly, have yourselves a fantastic day. See you guys later. In a video, end of Ls4 Monte Carlo rebuild. I think we're at part 4 now on this one. In a day, in the transmission.